Okay, thank you everyone. I'm happy to be participating with the session today. Um, and as you heard, I am currently in Nice, France. It's a very lovely city, and I just attended Embedded Recipes the last 2 days, and it's a smaller conference. It's a little bit of a regional conference, similar to Japan Jamboree. It's just one track but it's there was a lot of good discussions, and I'll talk more about that later. But right now, I'd like to go ahead and deliver my status of embedded Linux talk. A lot of you have seen this talk before, but I periodically just take a look at the status of embedded Linux. Again, this is not comprehensive. I can't cover everything that's going on, so I apologize if I miss something you're interested in. And this presentation has kind of two parts. I have what I call the fire hose shotgun part and the themes part. So I'll go rather quickly over some material. Some of this material I've delivered in the past because it covers a whole year. And so some of you may have seen some of this material. I'll go over older material more quickly. But then at the end, I'll slow down and talk about some themes that I've seen within the embedded Linux industry. So sorry for the speed. It's going to be a lot of information in a quick period of time, and I may go very quickly over slides. If you haven't seen this before, then the slides will be posted, they'll be available, and you'll be able to look up references if you have a particular topic that you would like to follow up on. So I have lots of links to articles and conference sessions and things like that. So let's talk about the Linux kernel to get started. The Linux kernel has been going very smoothly. The kernel development process, 63 days. In fact, about the most exciting thing that happened was Linus did not, for the 6.14 release, did not release on a Sunday. He released on a Monday. That's about the level of excitement we have with this process to be one day late. In looking forward to what we can expect for 6.15, we're currently on release candidate 6. So we're 6 weeks into the development window, or the integration window, rather. And unfortunately, that falls on a holiday in the US. The Sunday that we would expect it on, the 25th of May, is actually on a big holiday in the US, Memorial Day weekend. This is the first time I've used AI in one of my talks. I used AI to do a quick search and see if the kernel had ever been released on Memorial Day weekend, and it has not. There were no major releases, but there were some minor ones. So in 1999, so over 26 years ago, there was a release on Saturday. But it wasn't a major release. It was just a point release. And then there was one on a Tuesday, which is kind of close, but not the day of Memorial Day. So I don't know. I actually hope that Linus takes a vacation. So I think he should take more vacations. But we'll see what happens. That's coming up just in a couple of weeks here. So, and it doesn't really matter if the kernel is late by a week or early by a couple days or something. It's not a big deal, but it's just kind of interesting. Um, so let's look at some of those older releases and what they had in them. So in 6.10, we saw continued improvements in Rust support, encrypted interaction with TPM, so a secure channel to TPMs. Cryptostats was removed. This was a system used for keeping track of statistics on how crypto is operating, and apparently no one was using it. Um, there was no there was no outcry when they announced the removal, and it didn't really go through an obsolescence period. We also have the removal of some of the early alpha CPUs. Um, and the biggest thing I think in this release that was interesting was a bunch of work done to do memory allocation profiling. This is a system that put in instrumentation points to track all memory allocations in the kernel and keep track of which code was doing the allocating. Um, and it relied on a new system called code tagging, which was also added in this release. And it makes it really useful to tune to determine where memory is being allocated and what its lifetime is. And so if there are memory issues with the kernel, this is a really good system to have upstream. In 6.11, we had the new power sequencing subsystem that allows you to bring devices up in a particular order in order to uh, optimize how the power is used, or optimize the order. I'll actually talk a little bit more about that later. We had the sloppy logic analyzers. This allows using GPIO lines as a poor man's logic analyzer. So kind of an interesting embedded specific tool that was added directly into the kernel. And then a new runtime const macro, which is optimizing the use of values that are determined at boot time and never change. So this is actually rewriting the kernel at runtime. So self-modifying code. So a little bit frightening, but we've had self-modifying in the code in the kernel in other areas for quite a while. And this was right now only used in one place for um, high efficiency in a particularly tight loop in the file system code. And then in 6.11, we had a new VDSO implementation of Git random. So that VDSOs are kind of a substitute for system calls. They do something that looks like a system call, but it actually happens completely in user space. And that should speed up random number generation. And the extensible scheduler class was not merged this release. There was a bit of a dispute on the mailing list about it. It had been out of tree for a long time. People were really asking for it. And I'll get back to it. It actually came in the 6.12 release. So the big news in 6.12 was, of course, preempt RT got added to the kernel, and it's a little bit more complicated than that. But the biggest single thing in this 6.12 was the print K improvements. That was kind of the last major area of work that they were doing on real time. The security module also had some modifications that can now use static calls, replaces indirect function calls to improve performance. There's the ability in the tracing for the ring buffer that persists across a reboot. That's very handy. When you're tracing something, sometimes you'll actually get a trace, or you'll be in the middle of a trace intentionally when the system reboots, and there's not enough time to dump that out to persistent storage or to capture it in some other way. And so having the ring buffer persist across a reboot allows you to look in the next boot, you can see what was going on in that trace. So that's actually very, very useful. And then the integrity policy enforcement, it's a new security module doing a new type of integrity management. And then, as I mentioned earlier, the extensible scheduler class. So this is a new way to add a custom scheduler to the kernel. And interestingly, in one of the talks at Embedded Recipes, I heard a little bit more about this from one of the speakers. But that said they were using it. It was Steam OS, so a game company or game development company said that they were actually using this as part of their systems. But so there are actually a lot of BPF schedulers that have been out of tree for a while. People have been running some with some patches, out of tree patches to accomplish this. And a lot of like cloud providers have been writing their own schedulers for their workloads. It turns out that when you're running a data center or a cloud service, even small increments in efficiency can turn into a lot of money. So there's quite a few of these data centers that have tweaked the scheduler and created their own schedulers specifically for their data center workloads. And so this allows them to do that without having to interfere with the regular scheduler. So that's actually very interesting work, I believe. I do have some concerns about whether it would be good to get those schedulers upstream, but right now they're very custom. And so there's some resistance to applying them as general schedulers or tweaks to the general scheduling algorithm. So it's probably better that they're kind of, while they're in their experimental phase, that they stay out of tree. Um, let's see. Oh, 6.12. The other big news here was that 6.12 was selected by the Civil Infrastructure Platform for its next SLTS release. So CIP is taking on a lot of work here. They're supporting now 5 kernels for up to 10 years. I don't know how far we are into the 4.4 lifetime. I mean, that one will roll off eventually, but the commitment to support those for 10 years each is pretty nice. So if you have requirements to support a kernel, I highly recommend you adopting one of these from that's being supported by CIP and maybe helping out with that effort as well to maintain those. In 6.13, we saw some improvements in ARM64, the ability to run Linux virtual machines, and also support for user space shadow stacks. The set of patches called the lazy preemption patches have been merged, and I'll talk about those on the next page. There's a new thermal threshold system. And that is actually, I think, pretty interesting. We see a lot of power management things. So there are abilities to control power and CPU frequency, and those have an effect on thermal, but now you can actually get netlink notifications when a device crosses a particular temperature threshold, all the way up into user space. So you can have a user space manager for the heat on your machine. And then there's actually more Rust support added, particularly in the VFS data structures and interfaces, so that there was sufficient to re-implement Binder in Rust. So this is not, Binder is an Android IPC. And I think that's actually pretty interesting that there's now sufficient Rust support in the kernel to support fairly complex. A binder has always been kind of a complex subsystem in Linux that is used by Android. It's not used in production yet, this particular driver implementation, but I think it's heading that direction. I was talking to Greg Kroll-Hartman, and he said it's now there are alternate binder implementations in upcoming AOSP releases. So let me circle back to lazy preemption. So this is a set of patches to change the different preemption modes. There's currently several different preemption modes in the kernel. So preempt RT, which is one of the modes, is of course, the real-time one. But there were even if you're not doing hard real-time, you might have some soft real-time needs for your platform. And so there were other options: preempt none, preempt voluntary, and preempt full. But they're reworking it. The current way that they're handling it needed these conditional reschedule calls sprinkled around the kernel. And those are kind of inaccurate and hard to maintain. And so they are kind of they introduced a new need reschedule flag, in particular TIFF need reschedule lazy, so they can kind of lazily evaluate and whether they need to preempt in a particular spot. And Thomas Gleixner said that could, he estimates that you could result in the removal of up to 95% of the conditional reschedule calls, which this has actually been one of my big worries, is that with real-time upstream, that it would require a really, really huge effort to maintain. And this conditional reschedule, the fact that you have to maintain all these preemption points sprinkled all around the kernel, it seemed like a very, very big task to me. But if they can eliminate that, I think that actually solves one of the biggest long-term maintenance problems for keeping preempt RT working upstream. So this is really good. And I think it'll be very important work to follow. I don't think they're done yet. They're actually just starting the work to remove those calls. Also in 6.13, a couple of miscellaneous things. VFS supports multi-grain timestamps, which is a mixture of low resolution and high resolution timestamps. And for some particular types of workloads, they really need those high-res timestamps, but you don't want to use high-res timestamps everywhere because they're very expensive. So this is a nice compromise solution. There's a new madvise operation that installs guard pages, so some good code that helps your system be more robust, or at least to detect errors more effectively. The Riser FS file system was removed. F2FS supports some new features, a feature called device aliasing that allows a portion of the block device to be temporarily used by another file system. And you would have to read the article on that. You have to search and see why that's useful. So one of the things I want to point out for the 6.13 release also is in the actual build system for the kernel, there's now support for a couple of compiler optimization technologies. One is FDO, and the other is called Propeller. So FDO stands for Feedback Directed Optimization. And what this does is allows you to gather information using perf and other tools and feed that back into the next compilation of the kernel. And AutoFDO does this at compile time. Propeller actually analyzes the binary and does some things with just the already linked information. Well, and there's another tool called Bolt that does something similar and does not go back through the compiler linker, actually does it in place on the binaries. Anyway, all of these are automated systems for optimizing the um, the the performance of the kernel. And they do things like function inlining, moving blocks around in memory to get better cache utilization, handling registers better, increasing branch fall through. So these are all things that are at an individual level, any one of these would just be a minor tweak in performance. But when you add them up, you can get actually pretty nice gains up to like 10% or so in your performance on your particular workloads. Again, because these are using feedback directed optimization, this is code that will be optimized for your workload, the actual workload that was measured during one of the runs of the kernel. So I think this type of automation is actually very interesting. In 6.14, we had a new flag that allows you to use exec v at in a way that allows you to check the permissions of a script. So you can do security checks on a script, and this has not been possible before. So when Python or Bash or any other interpreter runs a script, they have to manage all the permissions themselves, and that's been kind of considered a security leak. But now they can just have the kernel give them the same information the kernel would do if it were executing the script. So the kernel doesn't actually execute the script. This is a new flag that was added that you can use a syscall to perform those security checks, and then so it makes it so that the security of scripts is just the same as the security for regular executables, which is, I think, a nice addition. And then there's a new DMEM control group controller that you can use to access or to regulate access to device memory. So some better control over how the system communicates with device memory. And then the Fuse file system is now kind of integrated a little bit into IOU Ring for some performance games. And then finally, the 6.15 release coming at the end of May or beginning of June. So I only found a couple of things here. The new kernel command line option, trace off after boot. This is interesting. It automatically stops tracing once the init process starts. So it's kind of a minor flag, but I happen to be very interested in this because I happen to be doing a lot of boot time tracing right now. And then Fuse now supports handling timeouts. So this is very useful to recover when the user space Fuse server or Fuse driver hangs. So those may be interesting to you. Looking at the kind of the kernel release status right now, the released kernel is 6.14. As I said, we're on 6.15 RC6, release candidate 6, and we've got these long-term kernels that are being supported for a period of 2 years. In some cases, a little bit more than that because they were promised. I think the 5.4 was promised to be maintained for, I think it was 4 years or 6 years. Anyway, but those will slowly drop off as they get older. This is a chart showing just kind of an overview of some of the major contributors by company and by individual top contributor from that company, what kind of things people have been working on. So you see, Bay Libre with 703 commits in the last year, Bootland with 635, Collabora with 496. And this is not to kind of start a race, but just to show you, who's doing what types of things and how much they're contributing. So Lenaro, Krzysztof Kozlowski, he's kind of he does a lot of refactoring, which gives him a very high commit count. But it's a lot of device tree cleanups and refactoring of things like the driver modules, driver subsystem. So you can see there's lots of GPU work being done. Obviously, a lot of processor support, Qualcomm, MediaTek, Freescale. A lot of these companies are actually consultants for the processor companies for their mainstreaming and up. So getting code for particular processors upstream. But you see, the IIO system, subsystem, and timers, network fix-ups. There's a lot of work being done all over the kernel by a lot of different people. So one thing I noticed was that Uwe Klein-Koenig actually switched from Pengutronics to Bay Libre. So, and he had a high commit count at Pengutronics, and he still has a high commit count at Bay Libre. So a lot of times the contribution level kind of goes with the individual person rather than the company. Or it's a good reminder that a lot of these contributions are coming really from individuals. So there's a really good resource. I've pointed out this resource before. It's from lwn.net. It's available for subscribers only. But if you are interested in kind of the release metrics, this is a great site. It's called the Kernel Source Database. One thing I wanted to point out, the 6.14 release was a little bit lower there. It had about 9,000, which is less than usual. Usually we're averaging about 12,000. 6.5 or I don't know, maybe it was a 6.6 release. Anyway, one of those releases had a very high count above 15,000. We're at kind of a normal commit count. I don't think there's anything to be worried about. If that line was trending down, that would be bad, but I think that's just a little blip. So just a couple of miscellaneous things. So Linus really likes imperative commit messages. One of the things that was on the kernel mailing list recently, well, at least in October, was he gave some instruction about how to phrase your commit messages, and he was quite polite about it. He said, "I would love to see people do this." So that was that's good information. If you are a contributor to the Linux kernel, it's good to use a consistent and kind of accepted way to phrase your commit messages. And then another thing that has been going on in the community is there are some people who are trying to get code into the kernel or try to do modules that either use GPL symbols come from in the wrong way, or actually lie about their own module. So there was the second of these patches is very interesting. So there was a set of patches to block one specific company's modules from using GPL symbols. It was Tuxedo Computers, and they have a module that's GPL v3, which is not compatible with the kernel. The kernel is specifically GPL v2 only, but they were kind of cheating by just labeling their module as GPL. So technically it is GPL, but the V3 or V2 really matters. And so it's a little bit extreme to see the kernel community actually propose a patch set that targets an individual company's modules, but that's what happened. And I don't know the resolution of this, but it was these patches. I don't know if they made it upstream, but hopefully Tuxedo Computers got put on notice here. Okay, in terms of technology areas, I'm going to go through this area uh, relatively fast because I know I've only got about a full an hour in total. So I just refer to a lot of event slides. And again, a lot of these are from last year. So last year at ELC Europe and at Plumbers, there were a lot of good talks. And I'll just point out some resources. And if you need, these are the links you can go to look up individual talks if you want to. One thing that's been started is the Boot Time Special Interest Group. I've put together, this is an ad hoc group. It's not, we don't have funding. It's just people who are interested in this topic. We have a monthly call and we talk about things that we're working on. The next one is May 27th, so a couple of weeks from now. And we have a boot time data repository. There's lots and lots of work to do. Here's some of the things that companies are working on. I'm working on boot markers and boot sequencing, and TI is working on something called Unified Boot Log, which covers both firmware, kernel, and user space. And so there's a lot of really good stuff going on there. In terms of the core kernel, we have capability analysis using source annotation. So this is interesting. So there's a way to check mutex ownership and lock semantics at build time if you annotate the source code. And these annotations map directly to directives that are provided by the Clang compiler. So this is only available if you're compiling the kernel with Clang. But it allows the compiler to detect thread safety violations and warn developers. So this is a kind of similar to some features that you might get from Rust in terms of safety. Um, and it does require annotating mutex and lock usage. But this is a good example, I think, of the types of things that the kernel developers are doing to use automated tools and toolchain features to improve the robustness and security of the kernel. Of course, we're seeing a lot of Rust development in the kernel, which is a whole language that has features for robustness and better memory management and things like that. And Greg Kroah-Hartman had says, I think I said this before, but Linus says the future of Linux is Rust. So if you are contributing to the kernel, you may want to think about maybe looking at Rust a little bit because it may be in your future. In terms of file systems, oh, there was this big blow up on the list about case insensitive file system. There were some bugs that Linus had to review and he just got really upset. Linus is pretty diplomatic most of the time, but he had kind of strong feelings on this one. But he gave some really good, interesting technical arguments and actually pointed out some history where case insensitive operations caused some real problems for the kernel. And so it's actually, the discussion is actually a pretty interesting discussion about how mature systems need to be backwards compatible. And these types of things are very, very tricky, in particular from a security standpoint. Let's see, here's some, these next couple of slides, I think I'm just going to go over real quick. There's a good overview of SD card and NAND flash hardware, some stuff about GPU driver development, and more talk about Mesa 3D and OpenGL AI. Some information about just mastering Ethernet drivers. If you're developing an Ethernet driver for the first time, that's a good talk. Bluetooth, deep dive. These were some of the topics from the networking track at Plumbers. State of buffer bloat, talking about cache usage and network stacks, that type of thing. Linux power management, their relationship and interactions, good overview, really good talk for an overview of power management. And this was interesting. Stephen Boyd was making the case that we need a new kind of subsystem to manage power at the SoC level. So an SoC specific driver manager So that's an interesting. And then PowerSeek is this new feature that was added in the 6.11 kernel that handles problems where resources need power before they can be detected. And it allows you to control the ordering of driver bring up. Anyway, so now on to real time. So this I've covered this before. Of course, we had the actual preempt RT pull request by Thomas Gleixner. That was done in Vienna last September. But there are still some patches out of tree, and I should be. So I just looked as of the 6.15 kernel, or maybe the 6.14. There are about 58 patches, which is 62 files, about 800 lines of code. And you can see some of the areas where those patches are. But I want to make sure that it's no longer so. Linux preempt RT real time is fully upstream, and you can use it now. What these patches are these are development patches, just like any other subsystem, right? So every subsystem in the kernel has a next branch of their tree where they have the patches that are going in for that subsystem in future kernels. So, obviously, just like any other subsystem, the real-time patch or the real-time feature is going to have additional patches as people find bugs or they think of additional extensions like the lazy preemption work I talked about. So we're going to continue to see work on this patch set and on this feature. And as you're using preempt RT, it's really important to report bugs because that real world testing is really useful to help make sure that we continue to keep the real time performance accurate and correct.
Right.
So there's some good talks about this. I won't review those. In terms of what's next, actually, one of the talks at Embedded Recipes just yesterday was a really great talk by John Agnes, and I have a little bit of that at the end. But okay, so let's see. In terms of security, there was this new proposal to use hashing instead of signing for secure module loading, and um, I won't go into all of this, but it's a kind of a weird way. It solves some particular problems with the keys having to be auto-generated, and in particular, it allows for reproducible builds. Right now, when you are signing modules, you have to generate some keys at build time, and the fact that you get new keys every build really messes up reproducible builds and kind of affects SBOMs. This whole long chain of events that is caused by that. So this solves a problem, but it's not a perfect solution. Anyway, I'm gonna skip over the security feature status update. A lot of security features are being handled now by tools. And actually, this is kind of plays into one of the themes I want to talk about, but I'll get to that later. But so you can see, so for GCC, Clang, or Rust, what kinds of features they support and what the status of those is. So do they check for zero call used registers, or do they zero call used registers? Do they handle structure layout randomization? Do they protect the guard? Do they provide a stack protector, forward edge CFI? That's control flow integrity. And so work is ongoing with all of the different compilers and languages to handle these and make the code more secure automatically. We've revived the Automated Testing Summit. Linux Test Project has a new release. Let's see, there were some testing talks. Toolchain track at Plumbers was interesting. And I'm gonna skip some of this stuff. We have the latest Yocto projects is Walnaskar. Oh, this says September 2024. That's not right. It was May 2025. I forgot to update this slide. Okay, and then if you're upgrading to ScarthGap, which is the 5.0 series of Yocto project, there's a migration guide available. One of the things happening with Yocto project is they're working on simplifying the kind of your first build. So there's a tool that's mature and has been used for quite a long time called CAS, which you can take a single YAML file and and it will download all your layers and set your configuration. And so it's supposed to be just like basically a one command line to do a complete build. Well, they're doing the same thing inside BitBake. So CAS is a tool that's outside of the Yocto project, but BitBake is kind of going to be integrated and do the same thing. Those patches are in flight right now. So in the future, it may be a lot easier to get going with BitBake. BitBake is notorious for having a very, very steep learning curve. So if they could do some things to reduce that learning curve, that would be great. The build root has had a new release in April. Uh, oh, and shell script. So template strings are being added to Python 3.14. They keep adding weird stuff to the language. Shell scripts, there's actually some work being done to do static analysis to detect bugs in shell scripts, which is a hard problem because shell scripts is kind of a funky old language. And the flow, in particular, the control flow, given that it's kind of integrated with external programs, is very hard to analyze. But people are doing it. So again, another example of people finding ways to use tools and modeling and static analysis to detect bugs and improve robustness. Okay, so I'm sorry for how fast that was. I know I skipped over a lot of stuff, but let's go through some industry news now. So I'll talk about trade associations and what was the other thing? Miscellaneous stuff. So here, this is a list of the groups inside the Linux Foundation that are working on things related to embedded. Um, Automotive grade Linux is probably the one of the most active ones. And there was some really good material at Open Source Summit Japan on kind of the status what's going on with AGL. And they had a Super Salmon release in February. And they've actually done a lot of stuff to migrate the distribution to Scarthgap. So they're using the latest major version of Yocto project. But they've got Flutter updates and BSPs for new chips. Um, and then the one I'm kind of involved with is called SGL. It's the space grade Linux, and I think I mentioned this before. We had a kickoff meeting in December, and hopefully we'll have. We actually, I'm talking to some of the Yocto project people today. There's a Yocto project workshop, and one of Philip Ballister has done some of the work on the initial distribution for the Meta SGL layer. So I actually going to talk to him quite a bit today about that. Okay, in terms of miscellaneous things, I think I talked about this OSS developer support pledge last time, but I want to cover this AI scraping. So just in the last couple months, it's become apparent that there's a big problem in the wider ecosystem, and this is just the kind of the internet. So the AI systems, there's a lot of AI companies trying to scrape the internet for training data, and the scrapers are not well behaved. They're supposed to abide by a certain set of conventions, but they lie about their user agent. They don't observe do not access standards. They change their IP addresses. They operate very much like botnets. They scrape very, very often, sometimes as little as every 6 hours. So even when the content has not changed, and they tend to scrape the full site, meaning sometimes they scrape every Git commit. So it's become a real problem. So 75% of the traffic to readthedocs.io was AI scrapers. And it's costing a lot of money. So, and the problem is a lot of the open source projects are free, right? They're publicly accessible and they're free to download, and the model always depended on it being humans that were doing the downloading. So Read the Docs did an analysis and found that it was costing them $1,500 per month just to support AI scrapers. And they actually had to turn off. So there are some sites that are blocking entire countries. Uh, I don't want to. Well, Brazil has been blocked and China has been blocked by some sites. And so it's a big problem. It amounts to kind of a denial of service attack, and it's costing a lot of money. Even some very specific sites like lwn.net has been affected. Um, And they've tried solutions like robots.txt or throttling, or there's actually code to do tar pits. They don't want to add gatekeeping. They don't want to make it harder for humans or add requirements like JavaScript to their own clients. So it's a tough issue. Even lore.kernel.org, I don't know if you've been out to Lore recently, but that has a new human detector on the front end. And it's not just scraping that's a problem. It's not just the additional traffic, but it's also fake content. So the curl project, which is a very important open source project, has reported a flood of invalid AI generated bug reports. And Stack Overflow has an issue with incorrect AI generated content. So this generate AI is looks to be a very interesting and useful technology, but it also has some downsides. And so we'll have to see how that shakes out. Another interesting thing is Ubuntu is going to allow users to experiment with testing of Rust-based core command line utilities, right? So there's a new tool. So right, the old core utils were written in C or C++, maybe, I don't even know, but they have had they had the GPL license. Uh, and these are core utilities. I mean, things like ls and ps and the very core of what you run at the kernel command line. But Ubuntu is going to introduce a new tool called Oxidizer that lets you test this new set of Rust-based utilities. And the idea, of course, is that Rust-based utilities should have less security issues and less memory problems and things like that. But changing the core utilities is a big task. And a lot of people are kind of upset because the Rust utilities are MIT. They don't like the fact that GPL is being kind of deprecated for this stuff. Um, but so that's again a big change in the industry. And I'm seeing more and more. Every conference I go to, I hear more about more tools and things being converted over to Rust or other languages. Um, Redis had to relicense. I gotta watch my time here. But they had switched to the server-side public license in March, and it's only been a year, and they've already had to kind of backtrack. And that's because the community in the industry created a fork under the BSD license called Valkey, and so that increased competition with a free fork. Well, not free, but a permissively licensed fork uh, and what actually an open source license, because server-side public license is not really open source. But anyway, Redis is now being offered under AGPL v3. I don't know if this is going to be enough to save that project. Valkey has quite a bit of momentum now. So it just shows you that you need to be careful if you relicense what the effect is going to be on your project. I'm going to skip over these, except I will mention this one. Okay, so NVIDIA has a Linux-based ARM AI desktop computer. And so we're actually seeing computers specifically designed to develop AI models or to uh, do AI training of large language models. Um, and of course, these are running Linux, but the interesting thing here is that we're seeing that this even exists, that we see AI specific user-based computers available in the near future. And actually, I mean, people are doing this with GPUs in their existing Linux desktop computers, but to have a specific dedicated computer, that's kind of a new twist. Okay, a couple of things about the community, just a couple of issues and conferences, and then a little bit about the eLinux Wiki. And I think I talked about both of these issues before, but I'll just review them real quick. So there was this removal of maintainers in October. A lot of people said, "Oh, you're just picking on Russian uh, individuals," and that was more complicated than that. There was a patch to remove maintainers, uh, specific maintainers from the Linux kernel source tree. And it caused a lot of concern in the community. There was complaints that there was kind of a lack of an explanation, and there was a lot of speculation about why this was happening. This was not a specific removal of all Russian nationals, because not all Russian nationals were removed, but just of individual developers who had been identified to work for specific Russian companies. A lot of people were upset because they said, well, geopolitics um, shouldn't the open source should be separate from what happened. This was the result. The reason for this actually was explained later. Is that some of those companies were on what is known as the U.S. OFAC list, or official Office of Foreign Assets Control Specially Designed Nationals list. And so it had to do with international sanctions against Russia. And the US was not the only company that has this type of list. It's also in the European Union, and actually Japan has sanctions against Russia. And so Linus and Greg are kind of required to follow the U.S. law. They can't just ignore U.S. law. And if the sanctions say you can't have business dealings with a particular entity, you have to not have business dealings with that entity. And so it's unfortunate, but this is, you have to live within the legal framework where you operate. And then another issue that came up last November was a code of conduct penalty. This is very rare. Most of the time, when the so the Linux kernel has a code of conduct committee that reviews. They receive complaints and they review the complaints, and most of the time it results in, what happens is just dealt with behind the scenes. They communicate with people, they try to smooth things out and correct misunderstandings. But in this case, the behavior was bad enough that it resulted in a penalty. This is the first penalty I've actually seen in about 5 or 6 years. The penalty was a decline to all pull requests from a particular developer. That developer has now apologized and is continuing to work in the community. So actually, this sounds like kind of a big negative thing, but actually, I think it shows that we have very good processes in the Linux kernel community to deal with inappropriate behavior. So I actually see this as kind of a positive thing. You don't like to see someone have to get penalized, but it does show that the processes are in place, and the community is a very friendly place, and people are watching out to make sure that it stays a friendly environment. Let's see. So let's talk about conferences in terms of community. The recent ones were Open Source Summit Japan, FOSDEM. I haven't had a chance to go back through FOSDEM yet. It's been all the way since February. I should have done that, but there's some interesting content there. There was an embedded track at FOSDEM. Linaro Connect is actually this week, and Embedded Recipes was this week. I'll just do a real quick overview of Embedded Recipes. Greg Kroll-Hartman talked about CRA. I'll integrate this material more in a future version of this talk, but he gave an interesting talk. So CRA, of course, is the Cybersecurity Resilience Act coming out in Europe. Becomes effective in 2020. Well, it's already implemented, but the penalties don't get starting doled out until 2027. And he talked about what are the OSS developers' responsibilities. The main thing is there's a few minor things you have to do. You have to have a security contact for each project, but OSS developers themselves are not on the hook for any penalties. Those will be the manufacturers. So if you're a manufacturer, you need to be concerned about this. And a lot of manufacturers are. So at Sony, we've been working on this for quite a while already, looking at, producing SBOMs and making sure we have good tracking of all of our software. I think most major companies are in good shape, but I do anyway. You should not be surprised by this. We've been talking about it for a long time. Alexa Rempel talked about a new kernel subsystem to store power fail reasons across boots. That was interesting. George Kiagiadakis gave a good overview about the relationship between Bluetooth and Pipewire. and Devarsh, and I didn't catch his last name, preserving video screen across the bootloader. Maxime Ripard talked about, he's from Red Hat, talked about functional safety for automotive. And Mark Vasut talked about the different types of firmware you find on ARM and how to safely update different pieces of those, different relationships. If you're doing uh, if you're doing secure boot, then there's a different collection of blobs. And if you're trying to do fast boot, you talked about Falcon mode on U-boot and stuff like that. Yeah, that was the first day. The second day, we heard about TPM 2.0, about SteamOS and Linux, and I think I have a slide on that one. Perfetto, profiling and tracing, really interesting tool for managing, for doing tracing. It's from Google. The Android team is using this, and it's very, very powerful. Allows you to do one of the things it does is it puts all the data into a SQL database, and so you can do queries to help you find particular issues that you might be in your tracing data sets. And then we had stuff about libcamera. John Ognes gave a fantastic talk about writing Linux real-time applications. I didn't have time to summarize it, but if you are doing real-time work, this is a talk you really should go look at. This material from this conference, it was recorded, and they'll be collecting the slides and putting the video online, and probably be available in a couple of weeks, but I don't know. It depends on their provider, their streaming provider. But we had CNC and 3D printing, Yocto, and OTA over the air updates. Turns out, this is something I didn't know, that systemd has a whole mechanism already for doing system updates built in. So, and this particular talk, Martin talked about, the relationship between that and some Yocto features. And you can see some of the other stuff that was talked about. Okay, so I didn't even have time to format this slide. Sorry about that. But Olivier Tilloy from Igalia talked about SteamOS and Linux. And this was particularly interesting to me because I work at a company that also does, a video game console. So the Steam company has some handheld video games and that are based entirely on Linux, and they have written their own scheduler, LovD, which is a SketchX scheduler. So they're using this new feature that came out in 6.12, and they showed some demos of how the system worked, and if you change the scheduler, you can actually get much better performance on the games. And they're also working on a bunch of other features inside the kernel that will be helpful, working on HDR, and also on hard disk encryption. And Valve seems to have a very good upstream first approach. Anyway, if you're interested in kind of gaming software, in particular gaming software for Linux and kind of the kernel operating system, technical aspects of that, this is a great talk to go review. The other talk I found really interesting was there was a developer who talked about using AI for embedded development and what types of things AI could be valuable for. And I recommend looking at this talk. There's always a lot of concern when you're using AI to generate documentation or code. You don't want it to hallucinate, and you don't want it to waste your time. But he actually tried to measure how much time it would have taken if he hadn't used AI versus how much time it took him using AI. And he found pretty substantial speed ups in some areas. In particular, he had the AI read his code and produce documentation automatically. He had it add test cases. He provided a single test case that kind of showed the style that he wanted, and the AI took that and created a bunch of additional test cases for him. It also found bugs in his code. All his demos were done with Claude LLM, and it really matters, he said, which LLM you use. There's a lot of LLMs that do not do as good a job as others, particularly with code management. But he also has some good tips for how to do it. I recommend looking at the entire talk if you have any ideas to do this. I know right now, AI generated code is forbidden in a lot of companies, and there are good reasons for that. We still don't know whether AI is legal. The training data, whether the copyright flows through the training data or not, is an issue, and the code ownership. Do you have a copyright? A lot of countries don't believe that AI generated code can be copyright, so that's also an issue. Anyway, conferences coming up. We have Embedded Linux Open Source Summit coming up in Denver in June, and ELC Europe coming up in Amsterdam in August. And we actually have our ELC 20th anniversary celebration planned. Yeah, we've been doing ELC for 20 years now, so that's pretty exciting. Then later in the year, kind of the two big events, Open Source Summit Japan in December and Linux Plumbers Conference also in Japan, co-located this year. And let's see. And I think I already mentioned that. Oh, one thing that came up about the eLinux Wiki, OS, open source, the Oregon State University Open Source Lab is kind of low on funding. And so we're a little bit worried about that. They're the hosts of eLinux Wiki. I don't think eLinux Wiki is one of their big development costs, but we are concerned. We don't want them to run out of money. They support sites and IT infrastructure for a lot of open source projects. Anyway, so let me just go through conclusions. I know I'm really, really short on time here, but I do want to talk about some themes and where we came from and kind of what I worry about. So one of the themes is AI is upon us. This was not on my bingo card for this decade. You can never, predicting the future is hard. And AI has come in very suddenly in the last maybe just 2 or 3 years with a lot of really interesting developments. But it's also come in with a lot of issues that it's causing. There's a lot of legal issues, kind of intellectual property issues, and it's causing this traffic problem right now with kind of unscrupulous AI companies abusing the open source and kind of creating a tragedy of the commons. So I don't have any solutions here, but I think it's upon us now. Something we'll have to deal with. I think also a big theme is the use of tools, compiler features, and automation to address robustness and security. So you see feedback-directed optimization, thread annotations, automated testing, and the rise of Rust is really trying to use language features and compiler features to automate things. The kernel code base is huge. You can't rely on humans to get it right all the time, and so we're going to have languages to help us improve things and keep things safe. And finally, a big theme I think is the community is more mature, professional, and friendly than it's ever been. So there's a lot of stuff that happens in the background, like the activity of the Code of Conduct Committee that we sometimes don't acknowledge or appreciate. If you look at the Linux Foundation, they really act as kind of the legal department, the HR department, the IT department, the marketing department, the intellectual property department. Most people don't realize the payroll and accounting departments and much more. Most people don't realize how much stuff happens behind the scenes. So that whole thing about like dealing with the international sanctions, you have to have a legal department for that, right? So, and the same thing happens with like patents. Most people don't realize the Linux Foundation works very strongly behind the scenes to address patent attacks against Linux, and nobody ever hears about it. And we want that. We want the engineers focused just on the technical stuff. But all of this stuff happens in the background, and it's actually, we have a very nice community because of all of these background actions. Not all of them by the Linux Foundation, but a lot of them are done without any notice. Okay, so just really quickly, I started working with Linux in 1993. That's 32 years ago. So I was involved in it with Novell at first. That's where I started, and then Caldera I spun out and worked at Lineo. I helped start the Embedded Linux Consortium And in that group, we had to do promotioning and marketing of Linux, Consumer Electronics Linux Forum, and then the Core Embedded Linux project. And a lot of that was, well, C Linux Forum was technical development, addressing Linux shortcomings for embedded. And the Core Embedded Linux project was more ecosystem building. We focused on events and online resources. Um, so we're living in kind of the golden age of embedded Linux. In the 90s, when I first got started, no one believed in Linux. It not only was it not popular in embedded, it was not popular on desktops, not in servers. There was no Git, there was no BitKeeper. Linus was using just patches and tarballs and email. That was all. That was it. There was no infrastructure at all. Email was the only infrastructure, really. There was no lore. LKML.org was just getting started, so there was an email archive. But you have to remember, this predated even Google. Google came out, I think, in 1998 or 99, somewhere in there. And so you didn't even have the search ability, right? So if you wanted to look at a previous discussion, you had to go actually read through archive messages. There was no methodical release process. It was just ad hoc releases. And there was no code of conduct. There were some communication norms, but it was probably kind of rough. There was no trademark, no legal protection. We only had one tool chain. If you compare that to where we are today, it's easy to, it's amazing. It's a huge difference. Like I said, we're living in the golden age of embedded Linux. But there are things I worry about, right? So I worry about AI. Will it help or hinder? AI is putting stress on open source ecosystems. It could introduce a new tragedy to the commons. We worry a lot about AI model collapse. And so far AI is good at copying, but it's not good at creating new technology. There's a lot of, I don't think the AI is going to be very good at kernel work. Kernel work is very much at the bleeding edge of a lot of technical areas. And if you don't have training data on it, which their training data doesn't exist for brand new technologies, then AI is not good at it. That could change, though. We don't know. Maintainers, I do worry about will we have enough kernel maintainers as the old guard ages out? So I consider myself part of the old guard. A lot of kernel developers are in their older years, in their 50s or 60s. And it's recently I've seen new young maintainers, and that's really good. I also worry about whether the tools, we're doing all this stuff with automation, will that break the network effects? So if, and that's part of the scheduler extension thing. So if we see people with schedulers that work only with their individual workload, that does not that can't be used by other companies, right? So the more we specialize the kernel into particular niches and do stuff that's not upstream, it has a bad effect. In particular, after FDO, the kernel that is run on in a data center might be quite different than the Linux that's running on other machines. And so I worry about that. Some things still take way too much effort. That's why I'm working on boot time right now, and because it's still too hard to achieve certain things. However, having said that, I have those concerns. I think we're doing really great. Embedded Linux is being used in billions of devices, and we have the core kernel systems are in place to support embedded. We always have hardware. It's been 32 years. I can't believe we're not done yet. We should have been finished by now. Anyway, so one thing to do is think about what's left besides hardware enablement, and there's always more stuff to do. Anyway, these are the resources that I get information from. And in particular, if you are looking for kernel information, you should use lwn.net. And actually, they just had an article recently saying that they have a little bit of financial issues, and they would appreciate it if more people could subscribe. So their funding could use a little boost. If you're not a lwn.net subscriber, I would recommend that you consider that. And that's it. So sorry I went over time just a little bit, but if there are any questions, I'm happy to take any questions now.
Thank you, Tim. Do you have time to ask questions?
Yeah, I have time.
Okay, thank you. 皆さん拍手しましょう。そして、質問、コメントある人。Hi Tim, I'm Hiroshi from Sony. Thank you very much for your great talk. Again, it's so interesting every time. And I have some question regarding Alti Linux because I work for automotive business and I often hear so many times hear that Chinese companies are heavily utilizing RT Linux to develop the autonomous driving systems. So my question is like so I'm just curious about that. Is there the relation between kernel community and Chinese companies are good or yeah? So I mean, so is there good feedbacks and yeah discussions and contributions from Chinese people, Chinese companies to improve RT Linux? Do you have any information about that?
Well, I don't have information specifically about Chinese contributions to like preempt RT. But I will say I'll just kind of ramble a little bit some of my observations. So we have seen in the last, I would say 5 to 10 years, we've seen very good participation by Chinese companies in the overall kernel community. So, I mean, we've seen the addition of kind of Chinese specific processors to the kernel, the Long March processor. We've seen, Huawei and other companies contributing and to lots of areas of the kernel. So I am not too worried about that. There was a time when China had its own version of Linux, and we thought that they might fork, and that was a concern. But I'm not too worried about it. The activity that I've seen and the acceptance that I've seen. Oh, sorry. The activity that I've seen has been very positive. Now, specifically with regards to real time, I do worry that there's only a very few specific developers that are very, very deep into Linux development on real time. It seems to mostly come from the company Linutronics, which is in Germany. And they seem to be the experts. Sorry, I have to stop that for a second. They but they seem to be doing okay, and I think they're also right now they're preparing a set of documentation that will help a lot more people get involved. And particular right now, I think the main concern is about application structure rather than the kernel facilities. So that's about all I can say about that.
Yeah. Thank you very much. Yeah, that's a very good situation. Yeah. Thank you.
Yeah.
他お話しています。
Thank you. Hi, Tim.
Hi.
I have one question about the kernel security. I think I asked you about it about 1 year ago. But since the situation has changed, I'd like to ask again for your comment. I understand the idea any bug fix is a security fix. Teams try to root. Uh, but I also think this idea makes many kernel bugs come still is.
Yeah.
This increases the work for engineers who check if the CVE is a real risk. I often use the page kernel Linux CVE announcement page. Every time I visit, I see a scraping check. Uh, I think many people may feel the same trouble. What do you think, Tim? Do you agree with Greg's current policy? Or do you think something should change?
Well,
I
that's a good question. Greg has fairly strong arguments that any bug can be considered a kernel bug, or I mean a security bug, and so they're now classifying basically every bug fix that comes. I'm very sorry. Uh, anyway, I uh, just a sec. I have an interruption. I gotta just give me one moment. Sorry. Okay. Yeah. So I actually talked to Greg about this yesterday, and he is getting reports from other people who are concerned about the volume of CVE messages, and so he uh, he understands the concern, but he doesn't have we don't have sufficient resources to categorize the bugs into different priority levels. Most of the bugs that are CVEs, I think, are uh, are bugs that are unlikely to appear or are very rare or low. Let's see, low severity. And so right now the problem is the main problem I believe is that he's not assigning like the priority level to the bugs. And in fact, the MITRE priority levels are kind of bogus in the first place. So to some degree, I agree with Greg's approach. I think it would be best if a group of people who were concerned about this volume problem got together and prioritized the bugs themselves. Because yeah, I understand that most companies' policy is to resolve all CVEs, and that has now become very difficult. But what needs to happen, in my opinion, is that you resolve only the serious CVEs, because not every bug report is going to turn into an exploit. A lot of the exploits are again, they're very difficult to create. They require physical access to the machine, or they only occur for like workloads that are unrealistic. And they're like file system bugs that are listed as CVE bugs, but they're really things that would just cause the file system to fall over. They wouldn't actually cause like a compromise of the security. So yeah, I think that the industry needs to look at maybe finding a way to help out and maybe refactoring themselves to not have the policy that they need to handle every CVE that's coming out of the kernel. But it's a good discussion. It would be a good topic to bring up at an event. I think we've tried to raise it with Greg at like Open Source Summit before. Anyway, so I don't have anything beyond that that I can relay.
Thank you.
Yeah.
はい、他ありますか？大丈夫かな。じゃあ最後にもう一度ティムに拍手をお願いします。Thank you.
Okay. Thank you very much, and I will talk to you later. Bye.